At least until the end of the year, we're gonna.
What do you think about the merge?
Merge? I think Ethereum will dump after the merge, honestly. Yeah. Yeah.
So the miners will dump.
Who knows? I just think that the merge is overhyped. I think I think Ethereum right now is way too high compared to Bitcoin. Oh shit, I'm being recorded. But that's okay. Not no financial advice in this class. Okay, I'll be back in like 2 minutes. Talk amongst yourselves.
Yeah.
Right now. The option changes instead of obviously metrics. Is that from the catalog?
Yes, I'm sorry. I'll do that. I'm going to upload this to the Notion page.
Thank you.
Yes, feel free to bug me on these kinds of things because I'm very forgetful. Also, like lecture recordings, if I forgot to post them, just keep tagging me anywhere and I'll get it done. Okay, sounder now. Done. Let's wait for a couple more minutes.
Good eyes on
All right, folks. Today is your lucky day. You know why?
Why?
I don't know. I just said that randomly. But today we get to play with MetaMask Remix, which is our like an online coding environment. You don't get free money, sadly, from MetaMask. But before we do that, we're going to go through some conceptual stuff. Okay. How was homework 1? I think homework 1 was due like a couple minutes ago or something, right? How did everyone do? Okay. So if you have trouble with it, make sure you post before the deadline, and ideally before the day that is due on Piazza, so we can get your questions answered. Okay. All right. Today we're going to talk about development environment. Okay. Now, last week we talked about the basics. You know, we finished up the concepts regarding what is Ethereum, and also we talked about what is kind of like what languages are there for people to write smart contracts, and you know, we kind of just did some. We just went over some general information. Let's do before we go into development environment, I want to do a bit of recap. So I'm going to keep doing this because this is important for you guys to know, okay? So how many kinds of Ethereum accounts are there? Can you tell me? Yeah, 2? What are they?
Contracts and accounts.
Human owned, but what's the proper name for it? Just speak up. Yes, externally owned account, that's right.
That's human.
Yeah, that's human. So EOAs are accounts with private keys that are generated from private keys. Okay. And who here remembers how smart contract addresses are generated? Yeah.
Is it a function of the deployer's address and deployer's nuts?
A hash.
A
Yes.
hash, yeah, hash
Yes.
of the
Yep.
deployer's address. Nuts.
Perfect. Yep. So in some sense, it's deterministic if you know when they're going to do it. All right. What are the 4 attributes of an Ethereum account?
Externally or?
Doesn't matter.
Well,
I mean, some fields could be empty, right? If it's one or the other. Yeah. But there's 4.
The nonce, the account balance, the contract code, and the contract data.
Yeah. So what does the nonce do?
Just counts how many transactions have been sent by that account to prevent double spending.
That's correct. You know, so we kind of talked about that, and then we went to talk about gas fees. Now, what is gas in Ethereum, and how is it calculated? Who remembers?
It's calculated by gas limit times gas price, or gas use.
There we go. Yep.
And it's just how much computational power you're going to use for.
And what's the difference between gas used and gas limit?
Limit is how much you're willing to use, and use is how much you're under.
Yep, perfect. And what is the gas price? How is it determined?
The market.
Yep, the market. So it's all about supply and demand, right? Because in Ethereum, because we're in 2022, actually, you know, we're in 2022, but Ethereum can only do like 10 transactions per second, which is abysmal. But it is a constant supply, right? And this is also why when people were aping into the ape coins or the ape land or something, I don't even know what it means. I don't even know if that's an insult, like ape coin, aping into something. Or the other side, there we go, that's what it is. So that's why kind of the gas price went through the roof, and people are actually paying more in gas fees. Like they're paying more in gas fees compared to what they're paying for the actual friggin' piece of virtual land, which is pretty insane. But people are really eager to get their hands on one. And when you have so much demand and the supply is fixed, then you know the price goes up, right? And who here remembers how we can, like, utilizing the concept of a nonce and also gas price, how can we cancel or replace a pending transaction?
So if your transaction stuck with not enough gas, you can send another transaction with 0 ETH, but do a higher gas limit, and then do the same nonce, and then hopefully that one will get added to blockchain. That it'll make the other one void because it's the same nonce.
You're mostly correct. So it's not the higher gas limit, higher gas price.
Okay. Oh, okay.
Yeah. So the gas limit, and gas used is so the relationship between gas limit and gas used is that the gas limit must be strictly equal to or larger than the gas used, because gas used is not flexible. Gas used is determined by how much computation or storage that you're using for this interaction. So that's dependent on how the smart contract is written. And because the smart contract execution is always deterministic, meaning that it doesn't really change, so the gas used won't change, right? And one of the reasons why we sometimes want to pass in a higher gas limit is that if the smart contract that we're interacting with interacts with some other smart contract, and in that case, maybe the total amount of computation is a bit fuzzy. So if you don't want the transaction to run out of gas and fail, we pass in a higher gas limit. And you don't have to worry about actually spending all of the gas limit, because it's just how much you're willing to spend, right? So the portion that's not spent won't be deducted from your account, right? And yeah, so we don't necessarily have to pass in a transaction that sends 0 ETH to ourselves or something, but basically you're able to replace a stuck transaction that way if it's too underpriced. Okay. All right, so that was some of the review stuff that we talked about. So today let's get into development environment. All right, so let's first kind of do an overview of the different stages of development. Okay, so this is roughly how things work when we start to do smart contract development. Okay, this is like a life cycle of how usually a decentralized application come to fruition. All right, so first we of course, before we write something, we gotta think, right? Got to use our big brains to come up with a unique idea, and not just a clone of Uniswap, cough, sushi swap, pancake swap. By the way, not financial advice, but pancake swap is usually full of scam projects. I'm just saying, so try not to use it. For some reason, Binance Smart Chain attracts scam projects. I don't know why. But first we got to come up with a good idea, right? And once we have the idea down, then we start to write a smart contract in Solidity, okay? And that's what we're going to learn first. And after that, of course, after you write your code, you have to test it to see if it works, because on the blockchain, it's not like traditional system. It's not like when you play video games and someone finds an exploit to like go under the map and shoot everyone or something. It's not like the developers can. I mean, in the Web 2.0 scenario, the developers can just push a quick hotfix, right? No, just fix the bug. But in a Web 3 application, because the smart contract is deployed onto the blockchain, you can't really change it, because by principle, everything that's on the blockchain is immutable. Now, again, there are, as I talked about before, we're going to get into how upgradable contracts work in the future. And actually, upgradable contracts, it doesn't break. Someone just joined the room. It doesn't break the principle of things being immutable. It's just it's a kind of trickery that they use, basically. But because you can't change things, and if your contract isn't upgradable, once you deploy it and you find some pretty severe issue, let's say you issued an NFT or something, you want to sell your own artwork, and if there's a bug that allows people to just mint without paying, which actually it's happened before, and actually it was actually a really big token pre-sale. It was one of the it's actually one of Blockchain USD's partners, BitDAO. So they're founding the education DAO or something, right? We have something to do with that.
Yes.
Yeah. So during the BitDAO token pre-sale, sadly I was there. I say sadly because right after the token sale, the price actually dumped lower than the pre-sale price. Anyhow, and so during the pre-sale, actually their smart contract had a bug, and thankfully no one noticed it. Actually, one of the VCs, one of the technical guys noticed it, but I don't think anyone took advantage of it, and I think they actually ended the auction early. But basically, they have this mechanism in their smart contract. It's more like a convenience method that allows the user to batch multiple actions together to basically batch mint or batch redeem or something. But they had a bug where you can essentially you only have to pay once and you can mint unlimited number of times. I don't think, as far as I know, and as far as actually someone, if you know the VC called Paradigm, I think that's them. So one of their technical guys found the issue, and the issue is it's actually really interesting. So basically, and later on you'll see that when we're writing smart contracts, we don't necessarily write everything from scratch. We take code modules written by different people, and we put them together. It's kind of like building a Lego thing, right? But the modules by themselves, in BitDAO's token sale case, the modules by themselves were fine. But then when they put them together, they actually form this vulnerability, which is basically when you're looping over a bunch of requests, it only checks the amount of money sent over once, meaning that you can basically add a bunch of requests afterwards, but it's only going to check how much you paid in the first place. And after that, it's basically free money printing for you. So this is basically another thing to keep in mind, and even more, it kind of shows the importance of testing, even if you're using audited and trusted modules. Sometimes when you put things together, unexpected vulnerabilities they come up. Okay, so deploying the contract locally for testing is very important, and we're actually going to get to that after the midterm, I think, and after we write a couple of our own smart contracts. Yeah.
So do you think they didn't test it locally, or was it maybe something that wouldn't show an error?
They just so the case is, so they were using SushiSwap's. So SushiSwap has this launch pad called Miso or something, and they're the ones providing the auction contract. And I think BitDAO just trusted that SushiSwap were diligent enough to look over their own code. And actually, there were a few more vulnerabilities, including basically anyone can start the auction at any time. They didn't add any limitations to it. So a lot of glaring vulnerabilities that got overlooked. I guess this is a case of BitDAO thinking, oh, SushiSwap, they have so much volume, I'm sure they know what they're doing, but apparently they didn't really look over their own kind of Dutch auction code, or it just kind of happened. I think that's the other problem. When you don't really know if a piece of code is safe when you kind of really look into it, but something like a Dutch auction or something that's used numerous times in the past, you just assume it's safe. But just because no one's attacked it yet doesn't mean it's free from vulnerabilities. And this is also why when you're writing smart contracts and you're writing any piece of software, you usually spend more time testing than writing stuff. And there's also this thing called this development paradigm in software engineering called test-driven development. Basically, you come up with the test cases first, and then you write the actual software to pass the test cases. But in our case, we just let our users do the testing, and when they find a bug, no, I'm kidding. But that's if you play video games, AAA video games nowadays, they basically release a broken game and then let the users pay $60 to test it basically, and then they'll fix things after a year and they'll pull the plug. That's usually how it works. But for us, because we're ethical people, And because this is the blockchain that we're talking about, you can't change anything. And you don't want to ruin your own reputation, because all it takes is one hack to ruin your reputation as a developer for a long time in the industry, especially in an industry where kind of the circle is not that big and everyone kind of knows everyone else. So you really want to test your code to make sure it's robust. Okay. So writing test cases. So there are 3 different ways, or really 2 different ways to write test cases. You can either write Solidity test cases or JavaScript to TypeScript test cases. We're going to do TypeScript test cases. And don't worry, I know it's another language that you have to learn, but trust me, it is it's kind of like learning a math formula, right? Everything's very, very, you don't have to do a lot of imagination. It's basically, it will feel like just plugging in numbers after you do it a few times, right? And after we do thorough testing, we usually, and these actually usually they happen at the same time usually with different developers. But if you're just running solo, then after that, you're gonna write a web front-end UI that basically enables the user to interact with your smart contract in a pleasant way, because not everyone knows how to do things with code and whatnot. So you gotta, if you want to increase the number of users that actually use your product, you gotta make it easy to use. Okay. And we don't do that. Okay. In this class, we stop here at test cases, because writing a web UI, that's like a whole other can of worms. And to be honest, I'm not very, I don't like writing web UI. I'm like a mobile developer, iOS, and I hate writing HTML stuff. And we're not going to learn that in this class. But if you're interested, there's an ITP on web development that you can take. That's pretty good. And after we write the front-end UI, we do what's called a Web3 integration, basically adding blockchain logic into your pretty-looking web page. Okay. And actually, this front-end Web3 integration is actually the code. It's basically the same as the test case. So for the test case, all you're doing is you're emulating how a user might use your product, both normally and in a like how basically you're trying to write a bunch of test cases. The first type of test cases you're going to write are users using your product normally, and the other type is users trying to break your product. Okay, so your product has to function normally when it's being normally used, right? In a manner that you expect. But if someone tries to do weird things with your smart contract, you should also stop them from doing that. Okay. And after we do the front end Web3 integration, we deploy the contract to testnet for further testing. So did we talk about testnet? I think we did, right? So testnet is basically, it's the exact same thing as the actual blockchain network. The only difference being the money on there is stake. So there's nothing at stake there. So you can deploy your stuff up there and you can get a bunch of ether from all kinds of faucets, basically web pages where people give away testnet ether that's worth no real world money. And you're able to interact with the contract. You're able to ask others, ask your friends and family, of course, to interact with your smart contract on the testnet. And if you find a bug, a vulnerability, or whatever, you can fix it, deploy a new one. There's no money lost. Okay. And when testing is done on the testnet, you deploy it onto the mainnet, which is what we call production. That's when you let the actual users interact with your contract. And hopefully by that time, your contract is bulletproof. All right. Okay. Any questions on this process here?
You're allowed to talk about what part of the process you guys are at.
We're at, we're past, like, we were past this stage since last June or something. So it's been a long time. Yeah, but we're constantly updating our web front-end UI, adding new features or convenience features really, and optimizing UI, doing facelifts. But the smart contract part hasn't changed since a very long time ago. Actually, I take that back. The previous version was live in July, last June. The current version has been live since May. But the smart contract, once we deploy it, we never changed it, because of course I wrote it, so it's perfect. Yeah.
If you wanted to change the smart contract, you just have to deploy a new one.
Yeah, and you have to hope that your old smart contract, like if it's a token and people actually paid money for it, then you're in a lot of trouble because how are you gonna reimburse the users, or you just don't, you stay anonymous, and you just leave. That's also one way to do it. Some people do that. That's what we call a scammer. But yeah, hopefully everything's good. But also you can make it into an updatable contract. Okay, I'll briefly talk about how upgradable contracts work. So in an upgradable contract, you make use of something called a delegate call. Okay, so think of it as this. That's a good analogy. Okay, let's say you have someone, let's say you have your own startup, right? You have your own startup, and let's say you hire a secretary, okay? And the secretary's job is to what does the secretary do? I don't know. Let's say an accountant, bookkeeper. Okay, accountant. There we go. An accountant. You hire an accountant. The accountant is perfect in every way except that randomly the accountant would just write like negative values onto the checkbook for no apparent reason. It's like a brain problem that the accountant has. Okay, a logic problem, not like a brain problem. Okay. So you want to. So what do you do? So what do you do in that case? If the accountant has some issues here. Yeah, because you can't fix what's wrong here. I mean, you can. Okay. In this case, you can't. Okay. So you fire the accountant, and then you get a new accountant that doesn't have issues up here. Okay. But do you also destroy the checkbook with the accountant? No, right? You keep it. So that's kind of how delegate calls work and upgradable contracts work. Basically, you're allowed to swap out the logic, but keep the storage intact. So imagine, so basically there's something called a proxy contract in the middle. So imagine the proxy contract being the office of the accountant, like the physical room, okay? And your checkbook is attached to this room, not the accountant. So when your accountant has some brain problems, and when you swap out that accountant, you're basically swapping the implementation in the sense of logic, but the storage stays with the room. So in the delegate call, the storage stays with the proxy, and then the proxy can point to basically, if you find a bug in your program, you can point the implementation to a new implementation, but then keep the storage intact with the proxy. So
Is the proxy just another contract?
a proxy, it's just another contract. All it does is it forwards the call to the implementation, but then the proxy itself actually keeps track of the storage, not the implementation. So you only use the implementation for logic, but the proxy keeps track of the storage. That's how you're able to upgrade the contract. You're just pointing it to a new implementation, to a new logic. And that doesn't break the principles of immutability because you're not changing anything, you're just pointing it elsewhere, right? Yeah.
So like when it points to another contract, the address of that contract would be held in the
In
storage.
the proxy contract, yes.
Yeah, okay.
Yeah, so when you upgrade the contract, the address that the user sees, that user interacts with, it doesn't change
Yeah.
because the users interact with the proxy. And then the proxy, when the user interacts with it, the proxy will check, okay, which implementation should I use? And it's stored in there, and then it will look at that implementation's logic and use it, and then keep the storage to itself. Yeah. So that's proxy contracts. Now you already know more than 50% of people in crypto. Yeah.
So for the proxy contract, how does it have a relationship with the other contracts? Is it about transaction?
What do you mean?
Can you like put logic that tells it to have that relationship with the other contract? For example,
So it's an opcode in Solidity. So it's built into the EVM. So the proxy is basically able to take the incoming data and then apply it. So basically, the proxy it's like a sandbox of some sorts. What it does is it takes the input data, whatever the transaction that user sent to it, and then it basically borrows the logic of the implementation contract, runs it within itself, and then keeps the results. So it doesn't actually modify the implementation. It just borrows this logic and then it executes it.
How does it borrow it, though? Does it have to like check with the other contract? Is that through a transaction or is that?
What do you mean check with the other contract?
So, where did it gets the implementation from the smart contract deployed that has the
Yeah.
actual logic, right?
Yeah.
So how does that, where is that relationship?
Yeah, so the proxy contract has a variable that keeps track of the address of the implementation that's going to be posted. Yeah, and also because the proxy keeps track of storage, there are actually rules in terms of how you should update a contract. Like for example, you cannot delete variables, and when you add variables, you can only add it to the back, to the very end of the variable declaration, because the storage is the same. And if you mess up the order, it's like I have a shelf and I have like a bunch of different herbs on it for cooking, right? And let's say when I cook, I don't look at what herbs I'm getting. I just remember the index. Okay, herb number 0. Okay, yeah, exactly. I just look at, okay, I'm gonna put some herb number 1 into it and then season it beautifully with herb number 2, right? You know, so let's say that's what I do. Okay, now let's say you buy some new there's some vanilla, I don't know. Let's say you buy some new vanilla. You didn't have vanilla before, you want to add vanilla into your herb collection, herb shelf, okay? Where do you think is best that you place this? At the end, right? Because if you put it at the beginning, then let's say herb number 1 used to be salt, and now it could be pepper because everything got pushed back by 1 and everything's messed up. And my dish is like horrible now, and I die after I eat it or something, right? It's the same thing with solidity stuff, right? Because the storage stays the same, and the order of the variables are important because deep down in the computer does not remember variable names. It doesn't care if your variable is named age or height or year. All it knows that it's a number at this position. That's all it knows. Okay. Which is why when you upgrade to a new logic, you got to make sure you don't negatively affect what was already there. Otherwise, it's going to try to read a number from a different number slot, or it's going to try to read a number from a slot that stores like a string, which will just crash the smart contract immediately. So you got to be careful with that, right? Yeah.
Once you upgrade it, can you go back to the previous, like?
Sure, you can. Yeah, you can point it back.
Okay. And it only like the declared like owner or
Yeah, the
employer.
owner. So
Yeah, yeah,
basically, I'm just going to go off topic a bit here, but I think it's relevant. So the concept of ownership in the smart contract, we talked about how smart contracts don't have private keys, right? It's generated like from the address and the nonce of the deployer, but you can build in certain access restrictions or privileges into a smart contract. Let's say in the case of a proxy contract, right? Internally, it keeps track of what implementation it's going to use. So who can change it? Obviously, you can't let anyone change it because you can't. It's only the administrator should be able to keep track and change it, right? So you built in a logic saying, okay, before I change it, let's say someone calls a function that I built in, like a feature that I built in that basically is able to change the implementation, all right? But before I change it, I have to check. Is this person that's sending the transaction the administrator? So you can also store like another address, which is the address of the administrator into the processing contract. And every time someone attempts to upgrade it, point the implementation to a different address, you check if the caller is the admin. So that's one way of how ownership is implemented.
Last question.
Yeah.
Doesn't that just like kind of defeat the purpose of the transparency behind smart contracts? Because you can have the owner
Yeah.
just switch up the like proxy contract and then
Exactly. Which is why after a while, if you're sure that your contract is bulletproof and whatnot, what people do is they just change the admin address to address 0 or something. So basically, no one's the admin anymore.
Yeah. Okay, interesting.
Yeah.
Thanks.
Someone else.
That was my question.
Okay.
Yeah, could you put multiple addresses for the admin?
So you can have.
Yeah, you can put multiple, and then check if it's included or something. Yeah, that's doable.
So then you could have like multiple people working on it.
Yeah, you could. Although that's usually not the practice, but it's doable.
What is the practice then?
Practice is if you're like a legit project, usually you use a multi-sig address as the admin. So when you're pushing, before you, so the logic to check if multiple people has approved of it or something, it's that part of logic isn't built into your smart contract, it's built into the multi-sig, which is separate. And again, okay, sorry. So you're saying multiple people have control over a single smart contract. That's usually not recommended, because then you'll be like, let's say you have three admins, then you'll be 3 times more or twice as vulnerable or something, 2 times more vulnerable compared to only having one administrator. Because if one of their private keys gets stolen, then that person can just do whatever they want.
And with the multi-sig, you would all need.
With the multi-sig, it's like you can set like however many person out of the total number of signers need to approve this upgrade action or something.
Gotcha, yeah, makes sense, yeah.
So is this proxy contract, what do you call it, like very commonly used for blockchain projects? to
It's
mitigate the risk?
very commonly used, yeah.
So most people do it.
Yes, and the proxy contract, because it passes through the proxy and then the implementation, it has a tiny gas overhead, but it's like very tiny.
Is that proxy made by the community or?
Everything is made by the community because there isn't like an official implementation reference or anything. But the community basically, they come up with a standard and then they vote on it and eventually it becomes like an Ethereum standard. And right now, yes, because it's been a long time since language come out and all of these things have matured more or less. So there is a standard out there that's basically called like a transparent proxy or something. There's also the UUPS proxy, or there are different types of proxies, but you can write your own proxy. The only problem is it's not standard. So a lot of the tools that are available, the deployment tools and whatnot, they're made to work with certain types of common proxies. So you'll just be giving yourself more trouble unless you want some extra functionality in those proxies. For sure. Yeah. All right, these are some tremendous questions. Do we have any other questions? It's good. We're very curious. Right. No more questions.
Explain
Yeah.
how multi-sig works, or that take a lot of time.
Well, multi-sig. Just think of. Let's say we have 6 people in this class, or you have 6 signers, and let's say you set a threshold of 4. So 4 people have to approve of this transaction before it's sent out. So basically, when the first person proposes this transaction, it could be temporarily cached somewhere, and not executed. So it's kind of like pending, right? And then the other people, can then approve of it or not. And when the last person just approves of it, it's actually the last person that triggers the sending action. So basically, when the second person approves it, the multi-sig checks, okay, I have 2 people that signed. The threshold is 4. Is 2 greater than 4? Is 2 greater or equal than 4? No, right? So it keeps waiting for more. So third person does it, 3 is smaller than 4. Fourth person does it, 4 equals 4. So now the fourth person will actually send out the transaction that was generated in the first place or something like that. Yeah.
So usually it would be one admin pushing changes and then like multi-sig. Those changes.
Well, it's usually one developer that's a part of the multi-sig signer, and then they will propose it, and then the others will sign off on it. But to the smart contract, the admin is just one address, and that address is the multi-sig address. So the complexities of the multi-sig shouldn't be a part of your application. That concern should be offloaded to the multi-sig, dedicated multi-sig contract. Yeah. And people usually, the multisig that people generally use is called gnosis safe. GNOSIS.
Oh, what?
Gnosis.
Oh, no.
GNOSIS. So you can play with it. I believe it is on. It's also on the test net, so you can play with it with fake money, or if you're a baller, play with it with real money. Any other questions so far? Great questions. Yes.
So is the reason why that the like gas fee is like exponentially larger than it would normally be because you like store the data on like the Foxy's like storage or?
Well, are you saying, is that why we usually opt for a higher gas limit than the estimate, or?
So like I'm asking, if you were to like use a proxy
Yeah.
in front of the logic layer, I would assume that you kind of like, if you like just like did 2 different transactions, you would like double the gas, you would potentially like include the, I guess like extra like transaction. Or you just.
It's a single transaction. It's a single transaction.
So you're just grabbing the code from the like logic layer address and like running.
Yeah, the smart contract. So it's built into the EVM. So again, it's a low level piece of assembly code called delegate call. So that that's basically something within the EVM implementation that does the call forwarding and then taking the logic and executing and saving the storage into the proxy. So it does all that with that opcode. Yeah. So you don't have to worry about how that works. So this is another difference between a higher level language and a lower level language. In Solidity, we consider Solidity to be a higher level language because all you have to do is just do delegate call and it'll do it for you. But for a lower level language, you have to do all that. You have to handwrite that yourself because it doesn't hold hands. Like sure, you can squeeze some extra, performance out of it, but then you would have to know how to do it. But in Solidity, like it's all packaged and ready to go. Nice. Any other questions? Great questions. All right, let's move on. Next step. So we have some development tools and frameworks. All right, the first one is called Remix. It is a web-based development environment. Okay, but usually serious developers don't use it because it is it's based in the browser. Anything based in the browser you can't take seriously, except for a product, of course. It is web-based. But anything when it comes to coding that's browser-based, you can't trust it. Okay. What if your browser crashes and there's no real save button because it auto saves, and I hate auto saving with passion. So I used to be a film major, right? So I used to edit videos, and for those of you who know who here has edited videos before? Okay, do you use Adobe or Final Cut? Premiere. Okay, so Premiere is a normal program. You can save like a normal person, right? But when Apple does things, they do it a bit differently. So first time I gave Final Cut Pro a shot, which is a video editing program made by Apple. There's no save button. And then they tell me that auto save had failed. So what am I supposed to do? So basically, the moment I couldn't save it manually and auto save failed, I basically lost 3 hours of work because there's no actual save button to save anything. And it's the same thing with the browser thing, right? If you lose connection or your browser has some error in the background, you don't see it. And then if you rely too much on autosave, sometimes it doesn't autosave, right? And also in the future, when we start writing more complex contracts and we start importing other people's code modules, you actually can't do it easily in the browser environment, right? And also, you know how it is with Chrome, your battery just dies with it open, right? So it's basically bad for a battery. It's not very reliable, and but it's very quick, right? You can open it up. You don't have to set up a new project, do all the setup process properly. If you want to test something out, that's what I do. So I call it a Solidity playground, because if I want to test some simple piece of logic, I just go there. I write a few lines of code directly. I don't have to set anything up because everything's like click, click, I can deploy it inside the browser as like basically this remix in the browser. It also includes its own fake blockchain that's running inside the browser that you can use to deploy contracts onto that fake blockchain and run it in the fake blockchain. So it's like really easy to test out simple functionality. But the moment things get complicated, it becomes very limiting, right? So very simple contracts, and just some, if you want to test something out, use Remix. Okay. Truffle and Hardhat, these two are basically Solidity development tools / plugins, right? So they both cover development, testing, and deployment, right? And personally, I use both. Okay. For Hardhat is better at development and testing, whereas Truffle is better at deployment. And this might not make sense to you guys right now, but I'll go over why they're better, and then you'll see how it is in the coming weeks. Okay. So the reason why Hardhat is better at development and testing is because when you normally run a smart contract, it's very difficult to check. Like let's say it's a more complex piece of smart contract. Like let's say you have like 100 lines of code or something, and let's say you're testing it and you call it with a certain input, but then the output is not what you expected it to be. All right. Then you have to start to try to figure out which line did I made a mistake on, or what went wrong and where did it go wrong, right? But smart contracts, it's actually before Hardhat came around. There's no way for you to inspect what actually happens inside of it. All you get is the output, and that's it. And you have to basically eyeball your code line by line to try and figure out what went wrong. Okay, you can't deconstruct the running process. But with Hardhat, they developed their own version of a local EVM. And what it does is that it allows you to print out variables to your window. Basically you can basically check what a variable is, the value of a variable on a certain line, so that you know exactly where things went wrong, right? Truffle doesn't have that. And Hardhat, trust me, it is such a time saver, all right? To be able to actually narrow down where things went wrong, because sometimes it's not that obvious, right? Even I get stuck on debugging, okay? Which is very unfortunate. But Hardhat is miles better than Truffle. But Hardhat is dog crap at deploying, because you not only have to write your own deployment script, fine, Truffle needs that too, but once you deploy with Hardhat, it doesn't keep track of where your contract's deployed. So if you deploy it and then you close the window, the only way to find out where your contract is to go to Etherscan, type in your own address, and check contract created or something. But for Truffle, it actually keeps track of the different versions of the contract locally in a certain file. You can basically get it in the future, especially when you start to write front-end stuff. It's very easy to be able to pull the address and the network and everything from a single file. So Truffle is just natively better at deployment than Hardhat. We also have this thing called ethers.js. So ethers.js is a framework that runs in your browser, and we also use it when we're writing testing code. So that's basically a framework that helps you connect to the blockchain part of things from your beautiful web UI that you'll never make in this class. Okay, so it helps front-end Web3 integration. Yeah, the question?
No, never mind.
Is there like a repository of different Solidity modules that we can use in our code?
You're thinking of Open Zeppelin, and we'll talk about it later. Yeah, so they have basically everything that you need. Yeah.
So when you were talking about Truffle, or not Truffle, Hardhat,
Yeah.
that before it didn't have this checking
Yeah.
Is the checking system that you're referring to similar to the one that's on like Remix, that would, like, if it doesn't recognize like your script, it has no.
Oh no, so that's when you're writing the code. What I'm talking about is when you're running it and things go wrong and you don't know what went wrong.
Gotcha.
Yeah.
So the Remix one is before even like
Yeah, it's just typing your code. It's not, it includes type, you can type your code there and then you can also run it. It's like one package for noobs. And we're not noobs, we're pros here, okay? We're pro gamers, so we don't use Remix, all right? I mean, we're gonna start off with using Remix for maybe one homework assignment, and then we're gonna go pro, okay? We're gonna do things locally. By the way, the things you see in those hacker movies, when they're just typing random crap and the screen goes like that, it's completely unrealistic. The more realistic thing is just sitting there for hours, like, why is this not working? And then you find out you forgot like a comma or you forgot something, which is really stupid. That's usually what happens. Yeah. Any other questions on this? Okay, let's move on to the next thing. There's something called a Web3.js. You might have heard of it. It's an ethers.js alternative. It's created by the Ethereum Foundation, which is why a lot of the earlier projects and also some of the current projects use it. They see this as a more official framework. Currently, it's maintained by a separate team. The pros is more official, and it's bad when that's the only pro. The cons is that the documentation is terrible. And it is so bloaty. Like when you're trying to install Web3.js, it just takes forever, and it just balloons up your package size. And that's really problematic in the future when you try to make like a web application and when the user's web page takes forever to load, you'll know that it's trying to load this Web3.js thing. It's just not good. So ETHSign, when it first started, actually, I was using Web3.js, but then I made the conscious decision to switch over to ethers.js. It's just because the documentation and everything is so much better, right? So you might see Web3.js somewhere else on the internet, actually in a lot of places, but just know that we're not using it. I just don't think it's that good, and even to this day, I don't think it really holds up to ethers.js. Yeah.
Is ethers.js open source or?
It is open source. It is maintained by one person called Rico Moo or something. Yeah, but it's maintained by this one person seemingly, which is pretty cool. I don't know if it's one person or not, but this is like the main guy. Yeah. All right. So let's talk about deployment, okay? So when we deploy, obviously we need to be connected to the network to deploy. Otherwise, we're just playing within our own little sandbox. That's not gonna do anything, right? When we're testing, we deploy it to our local fake blockchain, but it's a fake blockchain and people don't care about your fake blockchain, right? So if you want to deploy it to an actual blockchain that's running by all the nodes out there, how are we gonna do it? How can we do it without running our own Ethereum node, right? Like obviously the obvious answer is, if you run your own node, then you have access to a blockchain network. But I don't want to do that. I'm just a developer. I don't want to become a validator or something, right? So we have to utilize something called gateways, okay? So Ethereum gateways, or they also call node providers, all right? So gateways are full nodes, or they're full nodes, they're usually full nodes, that they grant developers access to a blockchain and perform various queries without needing them to run their own full node. So it's basically someone else running a full node, and they're giving you access, saying that, okay, you can connect to me, and then you can basically connect to a blockchain via my server. And of course, you have to pay, yeah. Usually there's like a free quota for everyone. But when things get serious, you usually have to pay for better availability or higher bandwidth or something, right? If your application becomes really popular, which is unlikely. I'm kidding. Right? But why do we have node operators, right? Node providers? Because full nodes are expensive and difficult to run. You need a decent computer to run a full node, right? And then it has to be on 24/7. Otherwise, if it's just periodically on, then you're going to spend all your time trying to synchronize, right? And managing your own server brings complexities, right? Who here knows how to spin up a Ubuntu server? even, I don't even know how to do that, all right? So it's like its own kind of DevOps topic that you have to learn about, which is, not really a concern to us developers. Because nowadays, usually different services, like if you ever want to run a web server, you can look to AWS or Microsoft Azure or Google Cloud Platform or something, right? We don't do that ourselves. Unless you're a Linux enthusiast, then you'll do that. But if you're a Linux enthusiast, I don't know. I don't know where I was going with that. But here's a Linux fact, okay? Remember what I said about the hacking movies with the screen streaming, all that stuff? It's probably just a Linux user trying to install a browser. That's what's happening. Anyhow, that's fine. If you don't get it, don't get it. Okay. But here's a question, right? If we rely on node providers, then aren't things centralized in this way? How are things decentralized if we're relying on just centralized servers that are giving us access to the blockchain? All right, and this is something that also I kind of talk about in our product. So basically, the node providers and gateways, they are not crucial. They are merely for convenience. So let's say all the node providers got nuked by I don't know, anonymous. I don't know why they would do that. But let's say all the node providers in the world got nuked. Are you now unable to access the blockchain? No, all you have to do is you have to spin up your own full node. Is it annoying? Yes, it is. But is it like impossible? I don't think. Oh, actually, if all the full nodes got nuked, then the blockchain is gone. So all the gateways got nuked. All right. So if all the gateways got nuked, you can still run your own full node. That's just a bit annoying, but like it's not like you can't do it, right? So we don't rely on them. It's just more convenient if we do it. We route the requests through them. Yeah.
So I'm a little confused on like how many times this needs to be done. So like, do you just use the gateway once and then now your smart contracts is on the network, or?
Yeah, well, it is on the network, yes, but whenever you want to interact with it, you still have to go through a gateway.
So like, say if you wanted to add like a proxy smart contract.
You want to read from it, write to it, you want to do anything, you want to have anything to do with the blockchain, you have to go through a node.
Even to read it?
Yeah, because if you don't go through a node, it means you don't have access to the blockchain, then how are you going to read it?
Gotcha.
Right.
I
So
just thought
think-
you could do it like on something like Etherscan or something like that.
Well, Etherscan runs your own node. So you're still going through a node some point.
Oh, okay.
With the
Technically.
interaction, yeah. So have you used MetaMask?
Yes.
So MetaMask has Infura node providers built in the address. Like if you go to advanced settings or something, networks, you can see that they're grayed out, but they're using their own Infura gateways.
So are they a gate? Does that make MetaMask a gateway themselves? or are
MetaMask
they
isn't a
using-
gateway, it's connecting to a gateway.
So they're
That's
using-
enabling you to
So you're
read
like
and write.
second hand using a gateway. through
Yeah,
MetaMask.
yeah.
Gotcha.
So think of the gateways as like your internet service provider. And the MetaMask as your browser or dial-up connection pop-up or something. So the internet service provider is what enables you to connect with the network. But MetaMask is just a way for you to do it. Now, of course, can you connect to the network without using a browser? Yes, you can. You gotta just open up the terminal and, well, the only thing I know how to do is ping google.com. But you can still do it, but it's just more annoying. And it's the same thing. As long as you have access to a node, you don't have to use MetaMask. You can use code, and actually that's what we're doing when we're deploying. We're using code to connect to the gateway to deploy it. But to MetaMask just adds like a nice UI for day-to-day interaction.
So there's still like the staking requirement?
The what?
The staking requirement for,
Yeah.
for example, you need like
Uh-huh.
32 ETH to run a node. Is that the same thing that we're talking about?
You need 32 ETH to run a validator to be considered when the proof of stake lottery is being drawn every block. But you don't have to stake anything if you just want to run a full node.
Okay.
Yeah, it's just that you won't be considered like you're not going to become a validator, basically. Yeah. So you won't get block rewards, you won't produce your own block and all that. You're just going to be constantly synchronizing with other miners or validators. Okay. Any questions so far? All right, so official public gateways can be accessed for free, right? So a lot of blockchains, they usually have their own free gateway to incentivize you to interact with their blockchain. For example, Polygon, they have their own official gateway that's free. Although that's like rate limited, meaning that you can't, like there's a quota for every single IP address or something. I don't know how they have it set up, but basically when you have like a high volume thing going on, then it's better for you to get your own private node provider, right? So here are some names: Infura, Alchemy, Morales, QuickNode. These are some of the names that you might see once you venture out into the wild west of developing smart contracts. MetaMask official, they use Infura because MetaMask is owned by Consensus, so is Infura, I believe. Alchemy is what we've used, and I think they have a relationship with the club, right? Yeah, so Alchemy actually has what is it, promo code or free tier? Like
We
a,
had it for like 3 months.
yeah, like a free plan or something. Yeah. Sadly, no one used it, right? It'll change after this class. Anyhow, yeah, so private node providers, the reason why they can guarantee stability is because you're not sharing it with anyone else. Ideally, they're spinning up dedicated instances for you, dedicated servers for you. And of course, you got to pay more, but when you have all that DeFi money coming in, that's not much of a concern, right? Okay, any questions here? Okay. Yeah.
Sorry, so Azure and AWS they're a type of gateway or
AWS is a server provider and service provider for generalized computing.
and then like
You can run your own node on an AWS generalized server. So it's like AWS lends out laptops, and you can, once you get the laptop, you can do whatever you want with it, but you're lending it from AWS.
Sort of like cloud storage, right?
Cloud, everything, AWS. Yeah, but like what you do with it is your own thing, but they provide just generalized service.
so what would be an example of a gateway like that's like besides MetaMask, like
Oh, MetaMask isn't a gateway.
oh it uses the gateway.
It uses a gateway, yeah.
So what would be an example that's like commonly used?
I mean, Infura and Alchemy, like these here, but those, like those, they probably partially, I actually don't know. Maybe they run their own server infrastructure, but some of the smaller ones, they might also, like actually these, they might also run on AWS underneath, but they just have like a Ethereum software running on top of the AWS virtual machine that's on the cloud or something. Yeah. So AWS is like, I can't come up with a good analogy.
I just wanted to see if I understood it correctly. Then.
Yeah.
So like AWS provides a service like say for Alchemy, and Alchemy is that Alchemy would be like
Yeah, like AWS, you can also use AWS to host your own website or something. Like anyone can use it for whatever reason. But maybe they choose to use it for running a full node.
Got it. Okay.
And maybe they also use, maybe they, they're not putting they're diversifying their server portfolio, which is also a good idea, not financial advice. But maybe their server stack is partially AWS, partially Microsoft, partially Google. But they're all running the same node software. So to us, they all look the same.
So are a high percentage of Ethereum nodes then hosted on these major by these major cloud providers?
We don't know. We don't know. We simply don't know. There are times that you're actually able to generate a profit by farming using an AWS, mining using an AWS instance, which is funny. But because the fees are changing constantly, so it's going in and out of being profitable and losing money. But there are guides out there on how to set up like your own mining operation on AWS. But usually what people do is they get like, they ship a container box full of ASICs, if you guys remember what that is, application specific integrated circuits. So they're machines, they're computers that can only do one thing, which is hash. They just, all they do is they find hashes. And basically they're like minor machines, right? And usually what people do is they put all those into like a container or whatever. Well, that's not usually what people do, but some of the more trendy companies, they put it into like a container box and then they're able to move it, ship it to wherever the electricity is cheap or something. Like Siberia, actually, no, Siberia is probably expensive, but it's cold, so at least cooling's not a problem. Texas, but obviously not during winter storm because no one has electricity. Yeah, but there are like a couple of startups that are doing this. Basically, containers with miners inside, and they can basically move it anywhere. It's like a self-contained mining operation. In China, they used to place these in the Sichuan province because there's so much hydroelectricity, so much surplus that's being produced. Electricity is like tremendously cheap over there. But then they banned it. Honestly, I think they banned it because like even after they banned it, right now China's running into like electricity shortages. So you know you can't. This is like the one time that the government didn't ban it out of spite or out of like trying to control currencies. It's probably just like being realistic, like there's not enough electricity, and we can't afford giving miners that when we can't even keep people's homes, you know, powered up or something.
You don't really think they were threatened by it, but they're new digital yuan?
I mean, they were, but you know, they've already banned Bitcoin like 10 times or something. I'm sure they are. I'm sure they are because they actually keep a very tight. They actually keep a pretty tight grip on, you know, the amount of money that you can send out. So actually, I think per person. Now we're going off topic here, but that's fine.
Digital yuan is scary.
Yeah. So basically, I think so. For every person in China, every year you can only send out $50K US worth of money to any other person in the US, and they keep a quota on both your end and the other person's end. So either one, when they reach 50K, you can't send them money anymore. And they can actually tell if you try to use other people to try to send money over or something. Actually, it's less strict on the receiving end, but on the sending end, they're very strict about it. So there's like a lot of currency control. I mean, imagine, you know, a digital currency, a cryptocurrency like Bitcoin, whatever, you know, where there's no concept of borders and whatnot, then, you know, the money can just float out instantly without like, and they can't control it because it's a decentralized system. They can't attack everyone at the same time. Yeah. Good geopolitical discussion.
Bitcoin at work.
Huh?
Bitcoin at work.
Sorry?
Bitcoin at work.
Yeah.
Doing what it was meant to do.
Yeah. Actually, you know, Bitcoin is actually kind of bad at being cash because it takes too long to settle.
It's good at wealth transfer though,
It's
in my opinion.
yes, because
Cash.
it's just adding a number in one place and subtracting it in another place. But as cash, I mean, you got to wait 10 minutes for it to be confirmed once, and there's like so much transaction fees. I think it's a good start, but obviously you can't use it as actual cash. All right, any other questions here? No more questions? Okay. Let's move on to the different types of networks. We kind of touched on it, but there are three kinds of networks. So there's the local network, test network, and main network. Okay. So let's start off with the local network. It is a fake blockchain, period. But you either start from scratch, or you can actually fork an actual blockchain from a certain block number, and afterwards you'll become the only miner on that network, right? So let's say, so that's good for when you need access to historical data, but then also you want to test things out locally. You can fork the real blockchain at a certain block number, and then basically run your own local fake version on your own PC, right? it often, and by default, it bypasses security measures such as difficulty, because you're just testing things. You want everything to happen as quickly as possible. So usually the difficulty is non-existent, and transactions are confirmed instantly because who cares? It's only on your computer. You don't need security. All you want is when you're developing, you need speed, right? You need that velocity. So there's basically like the security provided by difficulty and hashing proof of work is non-existent, right? Block time is negligible. Okay, it is basically a centralized database in that sense because you're the only computer operating on it. It's basically a centralized database. All right. Mainly, yeah. Okay, it's mainly used for contract testing and rapid iteration. All right. And also, because the block time is negligible, sometimes when you're developing things locally, you kind of have to keep in mind that on a real blockchain, you have to wait. Because when the block time is negligible, sometimes you start to make false assumptions about how things will run. That actually happened to me when I first started doing Solidity. I totally forgot in the real world, people have to wait for 10, 20 seconds for confirmation. And it kind of affects the way you write some front-end code, all right, and testing code. Any questions on the local network? Okay. All right, let's move on to the test network, okay? So the test network is an actual blockchain, all right? It is basically the same as the mainnet, the only difference being the currency has no value. So, transactions, you can be a millionaire on the testnet, but no one will care because it's fake money anyways. It's like you're a billionaire when you're playing Monopoly. No one really cares outside of that game, maybe, because it's not real world money anyways. And different test networks, actually, they have different consensus mechanisms, mainly to increase performance at the cost of security. But again, security doesn't really matter on testnets when everything's fake. It doesn't really matter, right? So we have four different testnets, and actually to this day, I believe three of them no longer exist. Okay, or they're being deprecated. So the first one is Robson. Robson is the closest to the main network conditions. It uses proof of work. The block time is usually under 30 seconds. Sometimes weird things happen on Robson. I think sometimes random people just spam the network for no reason besides pissing me off because I can't freaking get my things deployed because they keep spamming the network with useless stuff. Yeah, look, so it's vulnerable to spam attacks. Okay. Second network is called Kovan. It's something called proof of authority. Proof of authority is extremely easy to understand. Proof of authority is basically the node saying, listen to me, I am the captain now, and you listen to it, and that's it. So proof of authority is basically a centralized blockchain network where there's a number of trusted nodes that basically do all the processing. It's a centralized system, basically. But it is very performant because you have a small number of high performance computers. And you don't have to, the consensus doesn't take as long. And basically they trust each other, so they don't really have to validate each other's things. So it's very, very fast. Block time's around 4 seconds, right? And obviously this is not going to fly in the real world, usually. And then there's Rinkeby, also proof of authority, I believe. They have a 15-second block time. Rinkeby and I don't even know how to pronounce it. Gorley? I don't know. These two, they piss me off because in order to get any testnet ether from them, you have to post dumb stuff on Twitter. to verify yourself, like I don't care about that. I just want to get some test and ether to deploy my contracts and do testing, but like they make you do that. I'm not a fan. I believe Borley's also deprecated. I think Ring-B is the only one left right now. Aside from like, I think it's the only test network nowadays. Right? Any questions on the test networks?
How do they make money?
They don't. So the nodes running the test networks, they're usually a part of some foundation that has like that's, you know, they want to do it for the benefit of the community. Or maybe they're like part of the core protocol developers and just running their own nodes or something. But no, yeah, they don't get compensated. So it's purely an act of good faith or something. They don't get paid. Any other questions on test networks? All right, let's move on to the main network. I don't really have to explain what they are. Main network is the real deal. It's the network where everything happens legitimately, where money is real. All right. Currently, the mainnet is proof of work. It's planned to be transitioned to proof of stake soon. I have the soon TM here because for the past 3 years, every single year they're saying it's coming this year. It's like the boy who cried wolf every single year, but it's finally going to happen. It's going to happen, the merge. So basically the proof of stake network is already up and running, but currently it's its own chain. So between September 13th and 15th, we're going to see a merge happen. Basically I think they call it beacon chain or something, I forgot. But the proof of stake chain will merge with the existing proof of work chain and everything will become proof of stake. Wait, what day is September 13th, 14th? What day is it? Is it Wednesday? Let me check. We should host like a, right, Tuesday, Wednesday, Thursday. We should host like a watch party on some kind of, I don't know, Discord or something. Actually, we don't have Discord. Yeah, and actually, I say Robson, I also transitioned into POS by then. By the way, POS doesn't mean what you think it means. Robson doesn't, I don't think it's around anymore. So Ring-B actually, I think it's already transitioned into proof of stake, I believe. And the mainnet, of course, is only used for production after sufficient testing because everything happens for reals. Money loss is real. And you can't start over when someone loses money from your project. Everything's real, so you got to be careful. Okay, any questions on the main network? Alrighty, move on. Oh, extras like that. Yeah, we don't have to. These are all kind of outdated, so we don't have to take a look. You can take a look separately afterwards. Okay, so now let's talk about Remix, the Remix IDE. What does IDE mean? IDE stands for Integrated Development Environment. Basically, a program or a single window where you perform the bulk of your development. Okay. Remix runs in the web browser. You don't have to download anything. You don't have to set things up. You don't need to do all the yarn npm node stuff that we did. Okay. It runs its own fake blockchain inside your browser. It manages its own fake wallet with fake ether. Everyone starts off with like 1 million or 10,000 ETH or something, or 100. I can't remember. It's able to compile your contract and deploy it onto the fake local network, but also you can deploy onto the real network. Although you can't really write anything that's really complicated on Remix. All right. It enables developer to visually interact with contracts. So basically, when you deploy a contract in Remix, it's gonna have like a little window. You're gonna see it on the left side. It allows you to like point and click and enter values and click. It'll execute. Whereas if you do it using like hard hat or whatever in VS Code, you have to write the code to execute.
But here it's just point, click, and then you got it. Okay. It's easy to get started for beginners, all right? Because everything's so visual, point and click. But it's too limited. It also has poor performance because it runs in Chrome, and we all know how Chrome is. It's also difficult to use offline. It requires an internet connection to run it properly. There is an offline version that you can install, but all the images will be broken, you know, the broken image little icon. So all the image on that page will show up like that. And like, it just kind of triggers me and I can't bring myself to using it. So it's just, it's not a good choice, I don't think, all right? So we will make use of a simple calculator contract to demonstrate how this works, okay? So everyone go to Notion, download this slide, and on page 17, go to the two links here, okay? Do I even have the second? Oh, I still have it, nice. I didn't read it. Okay. The new profile this semester. All right, we got it here. I'm going to use light mode. Okay, so this is what you should see once you open up the remix link. Where's the theme? All right. Also, pink is my favorite color. So this is the second link. Okay, this is a this is a program that I wrote. It's basically it's a calculator. Okay, it's a calculator that kind of works like a real calculator, kind of, only more simplified. Okay, it doesn't work like a real calculator. But basically, it's able to add, subtract, multiply, and divide. You can also do exponents. Okay. It also has a memory built in, where you store the results in the memory, and then you can retrieve it later, right? So what I want to do here is let's go back to Remix first, and click on this. You should see like a bunch of stuff here on the left side, some folders. Go into contracts. Now you should be able to see 3 preset contracts here. Okay. We don't have to worry about them. You can delete them if you want to. I'll just keep them. And I'll click on this one. Okay, this button here. Can everyone see it okay? Should I, is this better? Yeah. Okay, let's click on this here to create a new file. We'll just name it calculator.sol. So SOL stands for Solidity. That's the file extension for Solidity source code. Okay. So what we want to do is we go to the GitHub webpage, click on raw, and then just copy everything over. Okay. And don't worry about what everything means here for now. Okay. This is just an example in order to demonstrate how Remix works. Okay. Okay. Now what we want to do is everyone here done copy and pasting? Who hasn't done it yet, or who's running into any kind of trouble? And by the way, if you're on Mac OS, if you have issues with Remix in Safari, use Chrome. Sometimes it doesn't work well with Safari. Okay. Although I admit Safari is the superior browser. Where is the file? It is in the link. In the lecture slide, page 17. Okay. Got it. Okay.
didn't say to run it, did you?
Huh?
Did you say to
Once
run
you
it?
paste, what do you?
Just wait here.
Oh, okay.
Are we all on the same page here? Okay, so on the left side, so on the right side, obviously, I don't have to, this is like source code, okay? And you can see that different things are colored differently. We'll get into that later, okay? Lots of colors going on. On the left side, there's this button here that looks like an S, okay? This is actually Solidity language, I think the logo or something. Just looks pretty cool, I think. You click on it, and oh my UI is kind of broken with the scaling. Oh, never mind, it's just broken. So here you can change the different versions of compilers that we're going to use. So all of these, you see it goes all the way back to version 0.1.1. That's when the language first came out. That's the first release. The most recent release is 0.8.16. Okay, it defaults to 0.8.7 because that's like the stable version so far. So another thing, you don't want to always use the latest version because it hasn't been battle tested yet, unless there's a feature that you really want to use. Just hanging back and using like a slightly older version is fine, but don't use like 0.7 or 6 or 5. That's like too old. Okay. And there are like a lot of breaking changes between major releases. By breaking changes, I mean that the same code will work for one version and not work for another version. Okay, so stay within the same major release, so 0.8 point something. As long as you're within that range, you're okay. But just don't go too far back, but also don't go too far forward. Okay. And this is even more edgy. Okay, so include nightly builds. They actually do. Okay, I build every nightly builds. But these are like even more, like so many different versions, like August 24th. Like that's like the latest version. And these are a lot more unstable. And generally, like you never do that. Okay. There's also this checkbox called auto compile, meaning that it will compile automatically. Currently, the things that we have pasted here, it hasn't been compiled yet. So if we have any syntax errors or we made a mistake or typo somewhere, it won't tell us. We have to keep manually clicking compile. But if you just check auto compile, we'll constantly check everything for you. Okay. So let me uncheck this and then let me add some gibberish here. You can see that nothing happens, right? It doesn't tell me that something's wrong here. It only tells me until I click this button and look, here's an exclamation mark saying that it doesn't know what the hell I did here. Okay. But if I do auto compile and I delete this, see, it went away on its own because it's automatically monitoring for change and recompiling. Okay, so just have that clicked on, have that checked.
What did you paste? What did you leave that?
Which one?
Oh, like you just.
Gibberish? No,
Oh.
I'm just randomly typing
Okay,
stuff
and
to
then
demonstrate that like without auto compile, you have to manually click this for it to tell you there's an error.
Oh, okay.
So you see it now, it goes away on its own without me clicking anything because it automatically tries to rebuild everything. Okay. There's also advanced configurations. We don't have to worry about these for now. Actually, let us worry about these for now. I'll explain this. So you see there are different, like, Joule, I don't know what it is. I know it's a different language, but I've never used it. And you see we have different EVM versions. And these names, what is tangerine whistle? I don't know what that is. But usually like these location names, they are basically different hard forks of Ethereum. So they represent major upgrades for the network. So basically you're able to compile your code and run it as if you're running it before a certain network upgrade. Okay, but we just leave it by default. By default, it just uses the latest, the live version of the network EVM. Okay. There's also enable optimization. Oh my gosh, this UI is horrible. Wait, even scale down, I can't see anything. This is such. Oh, is it? Oh, there we go. Okay, that's my bad. So we have optimization here. Now, what does that mean? Enable optimization. And what does this number mean here? So enable optimization, it just it optimizes your contract. So basically, it makes your contract smaller in size and cheaper to execute. So it costs less to deploy and it costs less for the user to run. But then what does this number mean? Okay, so this number actually represents the approximate number of times this contract will be called, which is ridiculous because it's like me building a statue and asking someone, what do you like? Can you give me an estimate of like this statue will be there forever? And this is like me asking, how many times will people ever look at it? Like, how am I supposed to know how many times people will ever look at it, right? But think of it this way: the higher the number, the cheaper it is for users to run it, but the more expensive it is for you to deploy it, and vice versa. Okay, so the default value is 200. It's like a nice balance between the two, and usually people leave it at 200. Okay, so that's optimization, right? So this number is usually confusing for people, and like it's going to be up there forever. It's immutable. Like, how am I supposed to know how many people will use it, right? But it's just it's a balance between deployment size and execution cost. Okay. And we can enable, it doesn't matter because we're running on the fake blockchain anyways. Okay. So now you see that we can actually publish it on IPFS, publish it on Swarm. So Swarm is something that's similar to IPFS. It's like a distributed file storage network. The only difference being no one uses Swarm. And the Swarm optimization to 1000. Okay, so if you raise it to 1000, it'll be just more expensive for us to deploy and slightly cheaper for people to execute it. That's all. So there's no real difference. Yeah. Well, I mean, there is a difference, but it's not that different. It's just, again, it's a balance. Yeah.
So is the pragma solidity the same? Is that different than the EVM version? Yeah.
Okay. So you see this up arrow here? It means any major release above this version, as long as it's within the same major release, any version above this is fine. So this is basically from 0.8.0 to whatever the next breaking change is. So currently I have it set to above 0.8.0, meaning that the 0.7 versions won't work because it's below 0.8.0. But if I do like 0.8.68, it can't work because it is still above it.
No, so my question is like, so when you go to the EVM versions, like you can see that you're saying that each of those names is a name for each hard fork, right?
Oh, okay.
So are each of those hard forks like related?
No, they're not related. So this is the language version. This is the compiler version here. So it has nothing to do with the EVM. So, okay, so compiler is the thing that turns this code that's somewhat readable in English into bytecode.
Sorry, can you repeat that? So the pragma is the pragma solidity up there is the version of the compiler?
Yes.
Okay.
So it's like
and the EVM, that's like the network.
That's the network, yeah. So
yeah.
So the compiler, so for example, so the bytecode that comes out on the other end is more or less the same, but newer language versions is sometimes fix bugs, sometimes add new features. It's like prepping, it's like smoking these meats, right? If you have different ovens, then you prepare the meat slightly different, right? Based on the oven's version, you prep the meat differently. So that's what it is now. But in the end, the smoked meats will come out smoked, and people will eat it. There's no real difference. But the difference is just that you gotta make your meats work with the oven. Okay, when you're smoking these meats. All right. No, a Zuck does. Anyhow. So yeah, there's that. Okay, any other questions on this page so far? Okay. So let's move on. And again, okay, let me finish up on Swarm. Don't worry about it. It's dead on arrival. it's something that Web3.js has built in, and the Swarm people are trying really hard to push it, but no one ever uses them. And this is not an official statement, but I think they're kind of scammy. I don't know. I don't like them. I joined the Discord for a while. I tried to use them, but it's not really good. Anyhow, so yeah.
Sorry, just a question about the IPFS. Is
Yeah.
that something that came before like Web3 or is that?
IPFS isn't a blockchain. It came before. I actually don't know. You can look it up. But it's basically a free and distributed file hosting thing where everyone can run their own IPFS node and you can upload things onto other people's nodes or whatever. But the problem being everything's free, so there's no real incentive for people to keep your file around. So I don't think it's very useful because you have no idea when the other person will just delete your file because you didn't pay them. You can't expect them to keep it around forever, right? But you're saying, well, I can run my own node and keep my own file, but then how's that different from just storing it on Google Drive or something, right? And there's and of course, nodes can replicate data from other nodes to keep the file available, but again, everything is free. There's no incentive to do so. And if you look up Filecoin is actually an incentive to built on top of IPFS to try to give people incentive to keep files around. Their business model is like you're basically renting storage from other people, but it's not done well. Yeah. It had a lot of hype, but now it's not doing so hot. They're desperately trying to get people to use them, but no one's using them.
So could there be like a coordinated attack on apes and then just try to find everyone who posts like the image of an ape and then get them to do
The apes, bored apes, their image is privately hosted. So they can basically rug pull all of your apes anytime they want.
So they could delete them and
Oh yeah, they can delete it and then your apes are gone. I mean, your NFT will still be there, but the image will be broken.
yeah.
Yeah. I mean, and they can swap it or something, or well, they can't because they have traits written into the NFT. So like there's proof, but like if they forget to pay their server bills, then all your apes will be gone. All the images, your profile picture will become like a broken image. The real end game for permanent storage is again I'm shielding Arweave too hard, but that's just how it is. Like IPFS is just terrible for permanent storage because it is not permanent.
You explain Arweave?
Arweave is a blockchain that and all it does is it's built to store files. So file storage is super expensive. So data storage is so super expensive on Ethereum, but on Arweave, because the blockchain is built to store files, it's very cheap. And the Arweave blockchain is actually, I think, 80 terabytes or 90 terabytes large. So it's very large. A lot of things are stored on there. And once you store on there, because it's a blockchain, by definition, they cannot delete it because it would just break the blockchain. So that's like a permanent storage solution.
You post on like art blocks, so they post all their stuff on chain.
What is it?
Art blocks.
Art blocks?
Yeah, they post all their stuff on chain too.
Art blocks?
You heard of them?
I've heard of Art Drive. Not Art blocks.
Like generative art.
Oh, I haven't heard. But if you go look up NFT tutorial on YouTube, they all use IPFS and they don't tell you that it's going to be gone just sometime in the future and no one knows when. They'll tell you, oh, it's free. Like, come on, there's no free lunch, right? It's got to be real. Let's be real. All right, so moving on. Okay, on the left sidebar, this button here below the S thing. So it's called deploy and run transactions. Let's go here. Okay. So you see, so there's environment. So that's the blockchain. Oh, sorry. Yes. So that's the blockchain I want to use. Okay. Remix VM just means that it's its own fake blockchain that's running inside the browser. Usually we just leave it at Remix VM, but you can plug in injected provider. Injected provider just means whatever wallet that your browser extension is using. So in my case, MetaMask. Actually, I haven't installed MetaMask on this Chrome profile. So injected provider will be nothing. Hardhat provider, for Hardhat, you can actually run the fake blockchain locally. Okay, and then you can connect to it from the remix thing here. You can see that it tells me to enter like an IP address or something. And this 127.0.0.1 just points to your own machine. Okay. It's also Ganache, which is bundled with Truffle. That's like another fake blockchain that you can run. And the other ones, doesn't matter. And external HTTP provider, this actually allows you to connect to an external gateway. Okay, so you can actually deploy things on chain for reals, I believe. But for now, we can just leave it at the default remix in London. And you can see that you get access to roughly 10 accounts, all of which have 100 Ether in it, right? Don't make money, unfortunately, all right? And you see there's gas limit, all right? This is a very high gas limit. It's set this way because just so that you won't run into issues with gas. Because it's a fake blockchain anyways, and this is with the gas limit high, and again, gas limit is just how much you're willing to pay, but not how much you actually pay for computation units. So it's fine if it's high value. It just prevents your transactions from being reverted due to blowing the gas limit. Okay, and value here, this just means sending a certain amount of money with the transaction, and we'll see that in the future, how that works in the future. Currently, contract, we can see that we have this calculator contract selected. Okay, and if it's selected to some other like ballot or storage, just click the drop down and click and select calculator. And then for now, we can click on deploy. Okay, we can see a green check mark here. All right, on the left side, there's something called deploy contracts at the bottom. We can expand it, and you can see we're now able to interact with this calculator smart contract. And this is what I mean by you can just point and click. Like you can just, let's say I want to add something. Okay, so I can just do like add 1 to 2 and transact. And if I get the memory, it'll give me 3. My result is 3 or something, right? So that's what I mean. It's very easy to interact with your stuff. Okay. So there, and also the reason why we're not seeing 3 return, but we're returning memory here. Actually, never mind. I'm going to talk about it in the future. But just know that. So this is the way you call functions. You interact with the contract, right? We want to divide something. So 10 divided by, let's say 10 divided by 4. Okay, let's see how that works. Because again, remember Solidity doesn't do decimals. See, 10 divided by 4 is 2 because there are no decimals. All right, it's only integer in Solidity. And you can just play with it. You can also clear, so that just clears the memory. Now the memory is 0. You can see here. Okay. Yeah.
Is Solidity strongly typed?
Yes. Yeah. You can see we have types everywhere. Yeah. Okay.
So were you able to see the solution?
So just click on Git mem. The reason why you're not able to see it right away is because I am saving, I am modifying the storage. Now, okay, so this is another thing. All these functions here, the logic here is contract code. Like addition will always be addition here, okay? But this variable here, which changes after every single operation because I override it with the result, that is a part of contract storage, okay? So the logic is contract code and this variable is contract storage. So after we deploy this contract, which we've already done on the fake network, we're not able to change the behavior of memory equals A plus B, but we're able to change this memory variable because remember we override it with every single operation. So that's the difference between contract code and contract storage. All right, any questions so far? Just play with it and see what happens. Yeah.
So when you transact, and like say for that one, when you divide 10 divided by 4,
Yeah.
Is your solution that you got, is that stored on like the blockchain network?
Yeah, yeah, that is.
And each time you use the calculator again, does that erase the previous solution or does it add on to it?
Erases it by overriding it. But then if you roll the blockchain back to before I did the second operation, you'll see mem being equal to the previous result.
So like the state will change.
The state will change, but again, in Ethereum, every state change leaves like, there's always an old state and a new state.
Leave like a footprint.
Yeah. You'll always be able to see what it was before. So it leaves a complete paper trail history of everything. And which is why you can't truly erase something from Ethereum, because all it takes is for someone to roll back to take a look at the block before the erasing happens, and they'll see everything before it got erased. Are we meant to see the answers to the problems? After we click, where do we find the output? Okay. So there are two ways to find the output. One is because I write the output to memory, to this variable, you can just click on get mem and you all see it. The other way to do it is once you click on transact and see that there's this green thing pop up on the console here. Okay, so this is actually a transaction log. You can expand it. Okay, when you expand it, you can actually see decoded output. You can see result 3 here. Okay, and we have 5 minutes. I'll explain why we have to do this. So the reason why this happens is because when you're calling smart contracts, when you're calling smart contract functions, if a function modifies the state, meaning that if it saves anything to the blockchain, the return value will always be embedded within this transaction receipt or whatever. All right. So you have to kind of look for the results. But if you just do like get memory, if you're just reading from it, then a transaction isn't generated. So you just see the results directly. Okay. Because whenever there's a state change, okay. So whenever we're modifying something and we're calling that function, what you get in return is always a transaction receipt, not just the result. The result is a part of the transaction receipt. Okay. So that's why, like if we do, addition add here, and you see it's happened, but where can you see the results? You got to expand the receipt and find the decoded output, and it's here. You just kind of have to do some digging work. That's just how it is when we're using the front end frameworks and whatnot. Okay. Because there are other information about the transaction. For example, what block was it included in, and you see like gas, transaction cost, execution cost, whatever, all that from address to address. Okay. And this is actually the input. I don't know what it looks like. Yeah, so it's just like a hexadecimal data thing. Yeah, and you're not expected to understand what that is. All right. Okay. Any other questions on how Remix works? Yeah.
Will we be using Remix the whole semester?
No, just for maybe one homework assignment. Because it really is, you'll soon find out that if you're a serious developer, if you're a pro gamer, you find out that this is more of a handicap. Oh, Amber Alert.
It's just telling you to stop using energy because it's too hot outside.
Oh, really?
Yeah.
That's bad.
All right. Well, the AC was broken during the first week, so now we're, Okay. Any other questions on all of this?
Why does it say IPFS not permanent?
It's not permanent because it's free, and when something is free, let's say I'm running an IPFS node and you uploaded your picture onto my node. Why should I keep your file if I'm not getting paid?
There's some protocol file.
Okay, so Filecoin is built on top of IPFS, but IPFS is also, you can just use IPFS standalone without the incentive layer. And that's completely free. And because it's free, there are no guarantees. So I'm not saying it's not permanent. If you ask me nicely, I won't keep your stuff forever. But again, there's no incentive to do so.
So are we past the incentive?
Filecoin is the incentive layer.
What about are we?
Arweave is a different blockchain. okay, Arweave is a totally different thing. Arweave is a blockchain. IPFS isn't a blockchain. It's just like
A non-profit company.
it's not a company, it's like a foundation or something. It's like the Ethereum Foundation, there's like the IPFS thing. Yeah, you can look them up on ipfs.io. They have a pretty sick website. Yeah, but everything is free. I don't even know how they make money, honestly. I don't think they do. Now there are no ads, nothing. What do you want to do with Remix? Homework 2 isn't posted. For now, just play around with it. Familiarize yourself with it, and I'm actually going to post homework 2 tonight. I don't think you'll be able to finish it because I think it involves MetaMask, which we haven't gotten to. But I'll post it beforehand anyways, so you can kind of get started. Yeah, homework 2 involves some Solidity programming and general programming questions. But I'll post it so you can get started on part 1. Anyhow, thanks for coming. That's it for today. Thursday, we're gonna create our own MetaMask wallets. Or if you already have one, you can use your existing one, and we'll play around with money, fake money.
Yeah.
All right, thanks everyone.
Thank you.
Thank you.
Yeah.
Thanks.
Yeah.
Yeah. That's